Welcome to this presentation on automating the assessment of network security in higher education. And the background to this is that we are looking at computer networks and security, the teaching of this subject. This is an engineering discipline, so we need to look at both theory and practice. But in practice, we might expect our students to build a secure network. So they would do so in a laboratory and by conducting laboratory exercises. We need to manage that laboratory so that we can set up these exercises for students to complete. And obviously we need to look at assessment. Now this presentation is based upon previous work. So if we look at a secure network, we might typically set up a network scenario with 2 or 3 routers, some switches, some computers connected to those switches, and perhaps something like an adaptive security appliance, as there is in this particular example. So this is a case study that we might use, which would involve securing the network at 2 sites. So the target systems that we often use for teaching networking and security would be virtual machines. So we might use the Linux operating systems, Windows. We might use simulators such as Cisco Packet Tracer or GNS3. And we might use network devices. They might be simulated or they might be real equipment. That will be routers, switches and security appliances. And it will be multi-vendor as well. So we might be using Cisco equipment, or we might be using industrial network equipment from companies such as Westermo. So this is our typical laboratory environment that needs to accommodate these various systems. So if we're looking at practice-based assessment, typically if we're going to look at network security as an assessment, we would need to design a security exercise. Then the designer would need to develop solutions, and then they would implement and deploy the exercise into a laboratory environment. And then obviously students would complete that work in perhaps a time-constrained manner. Then at the end of that, the assessor would extract the student work, and they would then compare the student work with their known solutions. And obviously what they could do is they could look at successfully completed number of tasks from a total number, and that would give us a result. That's one way in which we could assess our students. So then we decided to look at automation. Could we develop an application that could assess practical outcomes in the laboratory? So that would need to look at network devices and computer operating systems, whether real or virtual. We would need some configuration management. So at the start of an exercise, we would need to configure the environment. Then at the end of the exercise, we would need to read the configurations from the environment after the students have completed the work. We might need to run scripts before, during and after the assessment in the laboratory. We need to configure baseline template solutions. We need to define criteria and feedback for assessment. And then in the assessment, we would need to compare the students' work against our known template solutions. And then somehow we would need to generate feedback. So if we were developing an application to automate assessment of practice-based outcomes in the laboratory, these are things that we would need to consider. So what are the challenges? Well, we need to connect to these systems securely. So they might be routers and switches or operating systems, whether real or virtualized. So the answer to this we found was to use secure shell, which enables us to encrypt the connection. What about these template solutions? We'll use the configuration, so there will be configuration files on switches and routers and even operating system configurations. Those would be our solution templates. Then we need to account for variations in solutions. So for example, if a student used a variable name of in zone for a security zone, then there might be a variation. Another person might use input zone. So we need to account for those variations in variable names, and we can do so using wildcards. What about developing this application? Well, we could use rapid prototyping And we decided to use Visual C# because this enabled rapid prototyping and had been used for previous applications very successfully. So we needed a test methodology to test this new proposed application. So we developed a security case study. Then we implemented an insecure network and we saved the initial configurations. And then we implemented security on this network. Then we removed any original configurations from the solution. This is the first iteration of our solution template. So removing the initial configurations so that we're not assessing something that already exists. Then we add wildcards or remove variables. And we might add comments to our template. That's the second iteration of our template solution. Then we run the application and we compare the solutions against the final template. The result should be 100%. Then we get a third party to do the exercise. We extract their work from the environment and then we run the application to compare their work against the final template. Then we examine the output file and compare with the solutions. So this is a typical example of an initial configuration. So this is an example of a Cisco startup config file that you might find on a router. This is the configuration without any security applied. So this is part of the application where we allow assessment, placement and extraction. So we want to set up this exercise in the laboratory. Now down the right hand side you can see a list of PCs in the laboratory. And so we can then copy a folder containing our assessment, our exercise, to a remote folder on all of the PCs that we select in the laboratory. So this is the form that enables us to do that. And we can use the same form to extract, once the students have actually done the exercise, we can use the same form to extract the work from the environment. And this is a solution template. So you can see that these are the solutions to a security policy, some of the solutions. If there's a hash in front of it, that's a comment. If there are asterisks, 3 asterisks, that's a wildcard. So that enables students to use a variable name that might change, that they can use their own variable name. So this is part of the solution with wildcards applied. So this is part of the application where we allow assessment automation. So if we look at down the right hand side, you can see that there are a number of PCs and they could also be network devices in the laboratory. And you can see that we've got some template files onto the right hand side. There are about 4 of these in this example here. And those are configuration files taken from routers and switches in the laboratory. And over on the left hand side we have student configurations that we're trying to mark. This has been extracted from the environment. And we've also got an output file and a comments file. You can see in this example here the student has got a result of 103 from 127. So 127 is the number of lines in total number of lines from all of the devices that are being assessed, and they've got 103 correct lines correctly configured from 127, so their result is about just over 81%. And this can actually extract all of the student work from their folders or devices in the whole laboratory. So this will do it one by one. It will assess each student. It only takes a few seconds to do maybe 20 students in the laboratory, and it will output the result, as I say, into an output file and a comments file. The output file will give us a lot of detail. The comments file will summarize that how many lines that they got correct for each device and an overall mark. And the output for every student goes into a separate directory, into a separate file. This is an output file, and if the commands are correct, then it just says that, gives us the command. If they're incorrect, then it will tell us whether it's not found. There's an example of one of those here, a task not found with AAA authentication in this sample output here. So this is an example of the output with detail, and it will also summarize at the end how many lines are correct from the total number for each device, and then give us a total for the whole assessment at the end. We could also run commands and scripts during the exercise. We can enter them in a command list and we can run them interactively. So we might want to check to see whether students are saving their work correctly, etc. So these were the initial results. In this example, the template solutions consisted of 4 configuration files. There were 127 lines to be assessed in total. We found there were 5 lines in error. 2 were down to human error due to the assessor, and they could be immediately correctable. But 3 further errors required manual intervention. So we found that they were due to either false negatives, where a variable name was not wildcarded, that was easily fixed, or the application marked something wrong that was correct, or down to false positives, where command lines had been left from the initial configuration, and again that was easily fixed. So there were very few errors from 127 lines in total. Even after we'd taken out human error, there were just 3, so very low incidence of false negatives or false positives in the results. So in conclusion, so we're able to assess the security applied to a network. A small amount of work is needed to mitigate false positives and negatives. They weren't significant. So we need to allow alternative solutions as well. So the templates give one solution, but there might be alternatives. Also to improve the context of commands. So that might improve some of these false positives, for example. And perhaps we might look at an expert system in the future. But more tests are required on real equipment and operating system security. Also the feedback, we felt that the feedback commentary could be improved. But there's also possibly a commercial or industrial context here, because if you can assess student work, you can assess how well students have configured the security of a network, then it's possible to use this to see how well a computer network or a system has been secured, how secure it is, and come up with an assessment based upon that. And these are my references.